On August 12, 2020, Phillies outfielder BRYCE HARPER bunted for a hit against the shift. Now, this wasn't the first time Harper has done this. In fact, since 2019, the former MVP has bunted for a hit 6 times. But it left me wondering, should a hitter as good as Harper really be giving himself up for a potential bunt single when he could have hit a home run on that same exact pitch? Who really wins when BRYCE does this, the Phillies or the shift? Let's use math to find out. To figure out whether or not bunting against the shift is a smart play, we need to calculate the expected runs for when a player swings away and for when a player bunts for a hit. To do this, I had to create a formula. This run expectancy matrix shows the expected runs given each of the 24 base out situations in baseball, a league average pitcher on the mound, and a league average batter in the box. Then, to calculate expected runs given a specific batter at the plate, I used the following formula. The probability that the player reaches first base safely times the RE24 of that future situation, plus the probability that the player hits a double times the RE24 of that future situation, plus the same thing for probability of a triple and a home run, plus the probability that a player gets out times the RE24 of that future situation. It sounds complicated, I know, but it's not. It's essentially just combining the probabilities of everything that could happen in that specific plate appearance. Next, I needed to recreate this matrix for bunting against the shift. However, no MLB player has enough bunt attempts versus the shift to warrant a large enough sample size, so I instead calculated expected runs for the league average bunter versus the shift. On a given pitch, a league average bunter has a 49.6% chance of putting the ball in play. And once a bunt versus the shift is in play, the batter has a 58.1% chance of reaching safely. So using basic probability, if you give a hitter 3 strikes, the probability of bunting for a hit is just over 0.5. Then, similar to the swing away formula, you multiply the hit probability by the RE24 run expectancy, and that's the expected runs. As a case study for bunting against the shift, I created a data set using the 10 most shifted pure lefty and righty hitters versus the shift in 2019 according to Baseball Savant, minimum 250 plate appearances. The data set includes a good balance of elite MVP level hitters like Cody Bellinger and Chris Bryant, and below average hitters like Mike Zunino and Chris Davis. I calculated each hitter's expected runs with 0, 1, or 2 outs, facing a lefty or a righty pitcher, and every base situation except for any situation with a runner on third. I did this for 2 reasons. 1, often teams will not use a standard shift with a runner on third, especially versus lefty hitters, instead keeping the third baseman near third base to keep the runner at third from getting too large of a lead. And 2, I do not have enough data to accurately predict what would happen to the runner on third on a bunt. The runner could score, he could get tagged out, he could stay at third, who knows? Alright, the part you've been waiting for. What's the answer? Is it better to bunt or swing? Well, turns out it depends. I created 16 different line graphs for each subgroup and situation, and the results were fascinating. The number one trend to note is that with no outs, there are very few players who are good enough to justify not bunting, especially when the pitcher has the split advantage. Outside of Joey Gallo, who crushed lefties in 2019, the only player who should swing with no outs versus a same-handed pitcher is Cody Bellinger with a man on first base. However, as you can see, the expected runs bunting drops way off with 1 and 2 outs. For example, with the bases empty and 2 outs, the only players that shouldn't swing away regardless of pitcher are Mike Zunino, Chris Davis, Curtis Granderson, Brandon Belt, and Matt Carpenter. The main reason for this is that while bunting has a higher expected on-base percentage than swinging away, it has a much smaller range of outcomes, and therefore a lower chance for explosive scoring. Think triples and home runs. And with fewer outs to work with, it's harder to string together multiple hits in a row, so the potential for a home run becomes exponentially more important. Here's the same righty on righty with the bases empty graph, but on the right, the opacity of each line is that player's home run rate. As you can see, the players with darker lines have higher expected runs than the league average bunter with 1 and 2 outs, while Mike Zunino, who hit only 7 homers in 188 plate appearances versus righties in 2019, doesn't even come close. Again, I could make a multi-hour video breaking down every single data point here, so if you're interested in a specific player game situation, feel free to pause the video as I currently cycle through all 16 line graphs and data tables. Finally, back to BRYCE HARPER. Based on his 2019 stats, Harper should swing in these situations. So that bunt attempt on August 12th was a great decision by Bryce. He was facing a lefty with a man on first and no outs, and he increased the Phillies' expected runs by .019 by bunting instead of swinging. But what if Harper is better than a league average bunter? Over the last 2 seasons, he's actually 6 for 9 bunting for a hit. And while this is a relatively small sample size, it still allows for inference that Harper is better than average at bunting. Well, we can find the equilibrium point for any hitter, also known as the point in which the expected runs bunting and swinging away are equal, and therefore, how good of a bunter a hitter needs to be in order to justify bunting instead of swinging. To calculate this equilibrium point, we use old-fashioned arithmetic, setting X runs bunt equal to X runs swing and then solving backwards. While I'm not going to run through the math for every player in every situation, again, if you're interested in a specific player situation, leave a comment below and I'll get back to you. Here's one example. Versus lefties with 2 outs and the bases empty, Harper would need to have a 67.81% successful bunt probability to justify bunting instead of swinging. To bunt or not to bunt? That is the question. And while I sort of started to answer that question today, I definitely did not find the exact answer. There are still plenty of parts of this equation that I did not incorporate into today's video. For example, how good's the pitcher? I mean, if you're facing Max Scherzer, that's a lot different than facing a number 5 starter on a last place team. Another one, how good is the player on deck? Or even the player in the hole? Both of those things matter as far as how many runs you're expected to create as an offensive player. Here's one final one. Let's say you're trying to bunt, because that's the smart analytical play, but all of a sudden the pitcher throws 3 straight balls in the dirt, you have a 3-0 count. I mean, if you're Fernando Tatis, yeah, you should probably be swinging away. So again, these are aspects of this massive question that I did not answer today. So let me know in the comments below what aspects you want me to attack in a future part 2 episode of today's video. Until then, I've been Andrew Fenichel. Thank you guys so much for watching. This has been an episode of Analytics Breakdown. Make sure to like and subscribe if you enjoyed this video. And until next time, I'll see ya.